Hello. So we're going to look at integer values that satisfy an inequality. The word integer, that just represents all whole numbers. Okay, they could be positive or negative or zero. So what we want to do is we want to think about the whole numbers, the integer values, that k could be in this inequality. So this inequality tells me that k must be less than or equal to 5, but greater than -3, because all the numbers less than or equal to 5 go down way smaller than -3. Okay, so the first thing you just want to really do, there's a nice trick here, is you list all the numbers, including the -3, all the way up to 5. Okay, so they're all the numbers that are in between -3 and 5. Then all we need to consider are the two endpoints, the 5 and the -3. Okay, so 5, k can be equal to 5. That's what the little underline means. So yes, 5 should be in my list. But on the left-hand side of my inequality, I've got k must be greater than -3. So k can't be -3. So therefore we need to exclude the -3 from our list. So I just cross it out. And this is my list. Done. It's that simple. Okay. So listing the integer values that satisfy an inequality, this is what you need to do. Sometimes you might have, let's say I've got 4x is less than, let's say 16, but greater than or equal to, let's say, what should we say, 3? Okay, so this one's a bit trickier. So what I need to do is I need to work out the integer values for x that satisfy this inequality. So first of all, this inequality doesn't represent just x on its own in the center. It represents 4x. So what I need to do is I need to divide it by 4. And then I will just have x in the middle. So I can get away with doing this. I can divide all of these values by 4. Okay? So 3 divided by 4 is 3/4. 3 divided by 4. Greater than or equal to 4 divided by 4 is, that's just going to leave you x. And 16 divided by 4 will leave you 4. So now you need to consider all of the integer values that are greater than or equal to 3/4. Well, 3/4 could be 0.75, that's the decimal representation. So you need to think about all the whole numbers greater than 0.75, but less than 4. Okay, so let's go to the first integer that's greater than or equal to, well, greater than 0.75. Well, that integer will be 1. Then it will be 2, then it will be 3, and then this upper bound here will be 4. Okay, now we need to consider, are we going to include these end points? Well, 1 is definitely greater than 0.75, so yes, it's in, we don't even have to worry about the equals bit, it's definitely in this interval. But x needs to be less than 4, so we can't include 4, so we just cross that out, and this is my answer, 1, 2, and 3. Okay, so that's integer values that satisfy an inequality. So now what we're going to look at is solving inequalities. We can solve inequalities just like we do with solving equations. Okay, instead of having an equal sign, we have an inequality sign, and that's it. That's the only difference in solving inequalities. So for this first question, I want to work out the value of x that satisfies this inequality. So I need to rearrange it. I need to undo what's being done on the left hand side, but I need to do it to both sides of my inequality. Now remember, it's BIDMAS backwards really. So instead of multiplication being the first thing we do, we need to undo it. Okay, so think about what happens to x. The first thing that happens to x is I times it by 3. After I've done that, I add 4. So I need to reverse that. I need to take off 4, and then I need to divide by 4. So the first step is take off 4 from both sides, and I get left with 3x is less than 6. And then the next step is to divide by 3. I need to undo the times by 3, and I get x is less than 2. And that is your solution. So any value of x that is less than 2, if I put it into here, it will be less than 10. Okay, second example. Think about what you're doing to x. I'm dividing it by 5, and then I'm taking away 2. So I need to reverse that process. I need to add 2 to both sides, and I get left with x divided by 5 is greater than or equal to 3. Then I need to undo the divide by 5 by timesing by 5. That will leave me x is greater than or equal to 15. So any value of x greater than or equal to 15 will give me in here on this left hand side something that's greater than or equal to 1. Okay, last example, and then you can do some of the questions on the worksheet. So I've got 7x plus 3 is greater than 2x minus 12. So I need to get all my x's back over to one side. So it's the smaller amount of x that we move. 2x is smaller than 7x. So I need to eliminate this plus 2x from both sides. And the way I do that is by subtracting 2x from both sides. Okay, that will keep this balanced as it is right now. So take away 2x, I get 5x plus 3 is greater than minus 12. So now I just need to solve it. So think about what's happening to x. I times it by 5, I add 3, so I need to take 3 and then divide by 5. So I take off 3 first, and I get 5x is greater than minus 15. And then I divide by 5 to get x is greater than minus 3. So any number of x that is greater than minus 3 will mean that this left hand side is greater than this right hand side. And that's what solving inequalities is all about.